Okay, so welcome to the files, and we are learning about the advanced files operations in this particular chapter. So basically, when we do talk about file operations, we define a file. File, basically a set of data stored on a computer, often on a disk drive. So the programs can read from or writes to files. So basically, if I try to draw something very schematically, so you have a computer. I mean, you have the whole disk space in the computer. You have some memory, uh, you know, some memory here. Okay, we have memory here, and then your programming language is running here, your programs are running here. This is the program, this is the memory, and as an output of the interactions between the program and the outside of the world, you can have a lot of input and output operations. So what is an input operation? Suppose, I mean, the basic in its very basic sense, input can be like a file, you know, a file that, sorry, file that you read from your program, or output can be a file. This is the input, and output can be a file that you write from the program. So, and what does that contain? A set of data. So basically, we store the data. Now, um, it is used in many applications, like you have, like the PowerPoint. You use the files in the word processing, your Microsoft Word, or the databases, spreadsheets, compilers. Everywhere you have files. Now, in order to use file in a C++ program, what you need is basically a fstream header file. Always remember, like for example, in an average C++ program, we always use um, IO stream, right? You are familiar with that right now. IO stream is basically it ensures that your reading, writing stuff is covered. I mean, all the utilities are there for IO stream. Similarly, for files, we require fstream header file. Now, fstream has two branches, two sections. So fstream has two sections. Number one is ifstream, and number two is offstream. And as the initial letter suggests, I means input, O means output. So ifstream is for handling the inputs, and offstream is for outputs. And these are the data types. Ifstream and offstream are the data types. And fstream data, I mean, it uses the fstream data type for both input and output files. Now, you can use this symbol, I mean, greater than symbol, or this symbol to, you use this one for re for reading from a file, whereas you use this symbol for writing to a file. And it can use, I mean, whenever you use the file, you use end of file EOF member function. It is the member function of this particular class or this particular object. uh, this EOF member function you can use to test for end of the input file, because whenever you read through the file, you are writing a code, so you cannot visually inspecting the files. So the code must have some flag that will say that, well, my I mean, I've completed reading the file. I'm at the end of the file. So that's pretty much the EOF. So to summarize, this is an important slide. You see all the important resources for the files. Namely, you require fstream header. Now fstream has two parts, if stream and off stream. If stream is basically for handling your input file. You read the data from a file, then you use if stream. And if you want to write something to a file, you use off stream. And then you can use these symbols, these two symbols, for this one for reading, that one for writing. In fact, when we use the cout, this is also an input output handling. It's not file, but input output handling. So whenever you use, sorry, whenever you use cout, you use this one. And when you use cin, you use this operator. So that thing is applicable for the files as well. No exception. So fstream object can be used for input or output, and you have to specify mode on the open statement, and sample modes are in and out. This can be combined, and then on open call you can say dfile open. So let's do some example. I mean, rather than just discussing pointing things on a slide, let's make our hands little dirty by writing some code. So let's open up our Visual Studio Code, and here I do all the classwork programming. So let me create a new file and call it, let us say, if1.cpp. That is file one. That's pretty much the name of the program. So we can just create the file. So this is our file. This is our file, and then we have to use, of course, include input output stream. That's mandatory. I mean, because we are going to need it, because we will still doing that in and out stuff, you know. Then we can do f stream. That is another thing that is mandatory for the file operations. That is called f stream. That's what we were talking about. So we have to include this header. Then let's say we are going to use some strings in the, I mean, when we deal with the file, we can do string here. And then finally, we have to use using namespace std. So that completes our header and all formalities in the C++. And then we write our main program by this way, int main, and then we put return 0. This is our shell. We have been talking about throughout the class that this is our shell. We define this shell. Now we are going to write the program. Now, first step first, let's say, I mean, what we want to do, we want to read a line of data from the file. Okay, so we are going to use fstream. So we are going to use if, basically the input operations. Okay, so that's what we are going to use. So how do you do that? Let's say what we are going to do again, we will have a file. Inside the file there will be one line, and we are going to read that. It's a very, very simple example. So we can do like this: string input. This is our input, and then we can say fstream. Then we can say the file. That's the file object. Fstream is the class, file is the object, string is the class, input is the object. So now let's open the file in input mode. Okay, how do you do that? File, we write file dot open. Okay, and then we can give an example of a file. Let us say our file name is test.txt, and then we are going to open it in input mode. So what do we do? iOS in. This is our symbol for opening a file, opening this file test.txt in the input mode. Okay, so that's our basic file. So what we can do now, let's create the file itself, new text file, and we can tell it, we can say this is our file, and we can say John DOE, some person, uh, their address, let us say 101 Main Street, then we can say Los Angeles, California. So this is their address, okay? So let's close it. Yeah, this is our file. So basically the file is, I made a mistake because I should not make John DOE the file name. Let me change that. How do I do that? Um, Rename. Let me rename it. We can say john.txt or test.txt. That's what we were doing. Test.txt. Good. So that's our file, and then we can go back to the f1.cpp. So this file does exist right now. So now what we can do, we can simply let's say what did we do? These three operations. Let's see. So just a moment. Okay, so that's what we are doing. So that file we are opening now. Uh, if the file is successfully opened by this operation, you know, this is the way we can open a file. I mean, I'm not going to the extremely simple example because I guess that you have already covered, you have some background with the files. If that is not true, let me know. But let's start with a little bit good example, and then we can iterate on that. Now, uh, if the file is successfully opened, then what we should do, we should do if file. Okay, so this is the way we know that file is successfully open. So if file, then we can read an item from the file. So how do you do that? We can do getLine. This is a function in C++ that will basically read one line at a time. So now we can do file, and then another argument is input. That's what we are reading. So each line is stored in the variable input. Okay. So now what we can do, file is open. So we have the first line, we read the first line. Now we have to go through the file, right? So what we can do to read the entire file, what we can do while, you know, while file means where while the file is relevant, I mean, it's still open. Then what we do, basically we are reading the input, so we can do cout input end line. So we are reading the input. Now we have to read the next item, right? I mean, here we read the input in this line number 13, we read the input, I mean, some text. So while the file is still open, we basically write down the input to our on our screen, and then we have to go to the next line. So we can do get line, and then we do again file and then input. So that way it will basically um, read line by line. Now at the end of this operation, what we need to do, we need to close the file close. What happens if we don't close the file? Then there will be memory overload, and ultimately this will be very costly. So we don't want to miss this file close statement. And so ultimately we can do, I mean, like we started with, if the file is there open. So if the file is there, actually the file is opened, means if the file does not exist, you cannot open the file basically. So then cout, you can say that error opening the file. That is it. That is your program. It's a very simple program, but at the same time, it's not. Um it's a simple program, but at the same time, you can see that we are using most of the operations that you use for opening, basically opening a file and read a file. So we are focusing on reading a file. So going back line by line, so input output stream is needed for this cout stuff. Then you have the f stream. It is required for the file. String is required for holding the input as the string. And then what we did, we opened the file and then we went through line by line of the file. And finally, we closed the file. Let's see if I compile it. G++ and then f1.cpp, and also we have to do f1.exe, that will be our executable file's name, and -o. So if we some error is there, so what is happening? The main in function main, so is there, what is happening here? F1.cpp, so what did we do here? Um, Undefined reference to win main. So what is happening with the main? So let's see if we missed something. Oh, it looks like here. That should be fine. That should be all fine. Why we are getting this error in the first place? So we have undefined reference to win main. I'm just suspecting something is not compiling, or what is happening in function main. Okay, text dot startup. I don't know what it is. Collect two. So what is going on here? If I don't use this one -o, then what happens? Yeah, we have the same issue. So let's say um, I don't use anything. So just a shell. Can I compile the shell itself? Or well, I think the problem is I did not save it. This was unsaved. That's why it could not locate the main. This is a very common mistake people make. I also make that. In the Visual Studio Code, I assume that it is automatically saved, which is not the case. So now if I do, it compiles, and then we can do f1.exe, and then you see, I mean, we just read the file line by line. So we had John DOE, uh, 101 Main Street, Los Angeles, California. So we read it literally. So any question? So basically what we showed here, we can open a file and read a file. So that's about opening and reading a file. Um, so that's everything about when you reading the file. There are other examples as well. We are going through multiple examples, but so far so good. Oh, read the file. Um, so let me find some other example. Okay, now let's do another example where what we are going to do, we will read from one file and write the same thing to another file, so that we can show that how we can at the same time read and write to the file. Okay, so let's create another program, new file, and we can say uh, new file. Yeah, that's fine. No, we don't want the text file, we want a real file. New file, and then we can do f2.cpp. Okay, so open this one. So that's it. Now, as usual, we are going to use these three that we have used before, you know. So that is it, and then we can do using namespace std. That's also okay. Now int main, and then we can do return 0. So that's our shell. I mean, I'm repeating it because I mean we have to be in a habit to write this write program in that way. So we will start with the file name. So what we can do right now, we are going to be a little bit more interactive. We will even collect the name of the file from the user. So that's why to hold the file name, let's define this variable string file name. Then to hold a character at a time, let's define a character ch. Then if stream in file. So input file is basically in file. So it should be character. So that's it. Now let's open the file. There is, I mean, let's open a file to output your results. So for that, we have not done that, opening a file. So you can note that we are defining input file object, but we have not defined in our previous example how to open a file, open a output file. So here we did it little bit different way. Now we are doing explicitly if stream, and then we for opening the file it should be off stream, and then we can say out file, and let's say name of the out file is out.txt. Okay, that's it. So that's how you can open a file to write your output. Now let's collect the name of the input file. Let's say cout. You can say enter file name. That's the input file. You are collecting the name of the input file from the user, and then user writes something, and then you write, you do cin file name. Okay, so if we do that, then you open the file for input. Okay, so this file, whatever in file you pass, you have to open it for the input. This is the same in file dot open, and then you write file name. Okay, so that's how this is the file name. You read the file name here, and you open this file for reading from. So then if the input file is open indeed, you write in file. That's the standard way. Then you can do read a character from file 1. So in file, and then you can say dot get ch. Okay, so while the last read operation was successful, we can continue. So we can do while um, in file, that means your last read operation file is still relevant. Then you can say out file. Okay, dot put character. So same character you are putting in another file. So read, then what happens next? Read another character. You write in file dot get ch. Okay. So then it keeps rolling out. It keeps revolving until in file is done. So that's how we do it. Then what happens at the end of this operation, after this in file thing is done, we have to do in file dot close, and then of course out file dot close. That is it. Now you can say cout, and then you can say file copy is done. Okay, that's it. Now what happens here is you started from there, you got there. So basically actually we need to do it inside this one, inside this in file relevant of while in file is relevant. So this one, this loop. Otherwise, else standard thing, that is cout error opening the file. That's standard error message, and we can that's it. That's all about this program. Okay, so what did we do here? Let's see. So we started with in a standard way. Now, compared to the other one here, what we are doing, we are reading uh, line by line. Sorry, character by character, not line by line. So that we are reading every character and then we move forward. And then what we do at the same time, we are, instead of outputting this character, we are just putting it inside the file. So you can note here what we do in file.get, it actually unfolds the character from the in file. But when you do the put, there is a function called put, member function. Put, put actually places a character inside the file. So once everything is done, you have to close the file in file, you have to close the out file, and you will see that your out file is saved inside your program. I mean, inside your directory where you are running this program. So let's try to run this code. G++ dash O f2.exe, that is your executable file, f2.cpp. So again, oh, I did not save it again. You see, I mean, that's the same mistake I have done. So if you compile it, now it's compiled, and then we do f2.exe. Enter your file name. Let's use the same file name as before, f2.test.txt. So your copy is done. So we should get the out.txt somewhere here. So MNOP, you see here out.txt is created, and you see everything is copied literally, So that's how you can copy. So here in this example, why it is different? Because we learned how to open a file. Of course, we learned it in the previous exercise as well, but here we have done it in a different way. We did not use the F stream. We use directly if stream and off stream. If stream is for opening a file, input file, and off stream is opening an output file. So basically what is happening inside the file, there are contents, there is data. Now the data is streamed, we are creating the streaming of the data, just like you watch Netflix. What happens in the back end, there are files, there are files of movie, let us say MP4 file. And then what Netflix does, it streams that Netflix file. So it reads the MP4 data some way. I mean, not in this way, some other way. It reads the data and then it transmits the data. It shows the data on the device screen, you know. So that's pretty much the input output operation with any streaming platform. So here also we are streaming, but in a little bit smaller scope. I mean, it's not Netflix. We are reading the data from a file and writing the same data into another file. So we did if stream, off stream, and then we simply went through. I mean, opened the file, of course, and then we went through the file. I mean, if the file is opened correctly, then we get the character, and here if the file is still opened, we are putting that character inside a um, inside your inside the output file, and then we read the next file. If the character is read successfully, then only it will go into the next iteration, otherwise not. So ultimately, at the end, we are closing the in file, we are closing the out file. And then finally, we say that file copy is done, and that is it. And we have shown the example that it works. I mean, this process works really. So, any question so far? Okay, okay. So, you can there can be multiple other examples as well. We'll go through those. Let's move to the slides. So we have done this. So, you know, there are multiple file access flags like iOS app. So it is in the append mode. We have not done this. So we have to do it. You know, this is something we have to do. Then iOS 8 is a file, or if the file already exists, the program goes directly to the end of it. Output may be written anywhere in the file. You can have another mode, the binary. The binary files, it's a different kind of file, because when you use, for example, when we compile the program, we get a.exe or f1.exe, f2.exe. These executable files are necessarily binary files. So you are opening the file in a binary mode. So when you open a file in binary mode, data is written to or read from its pure binary format. Sometimes it is important, there are multiple file transfer protocol. There is a file transfer protocol called FTP, file transfer protocol. I mean, literally. So there you use those binary mode. Sometimes you transmit binary file, automatically it chooses binary mode. If you transmit an ASCII file, it will choose the ASCII mode. So iOS in is the input mode, iOS out is the output mode, iOS trunk is the file already exists, it contents will be deleted or truncated. This is the default mode used by iOS out. So if you open a file with iOS out, be 100% careful that the file does not exist in your area. Number one. Number two is no useful data is there, because once you open it in uh, out mode, it all contents will be deleted and you will get a fresh file there. But in that case, how do you make sure that you are not you are appending? So this mode, iOS app, basically, if the file exists, its contents are protected, these are preserved. And so what it does, it points your file writer to the end of the file, you know, so that when you write something, it is appended. It's not just, it's not overwritten, it's appended. So that's the important thing about the access flag. We'll do examples on appending as well. So we have done it basically. So default file opening modes, you can see ifstream and offstream. So it is open for input only, it's open for output only offstream. Um, ifstream file cannot be written to. So if you open a file using ifstream, then you cannot just write to something. I mean, you cannot just use it for writing purpose. And then open fails if the file does not exist. And file is created if file does not exist, and file contents erased if the file exists. This is very important. The last one, it is deleted or truncated. So, we already have gone through this. So file output formatting is the next topic to discuss. Um, we wrote the file, but how do you format the output? That is our next, like, uh, next problem, next challenge. Okay. So now, in order to solve the next challenge, let's go through some code. Let's write some code. Rather than reading the slides, I prefer to write the code. That is easier for both of us. So f3.cpp, let's open it. And then what we should be doing here, will be formatting, output format. So for formatting, in addition to IO stream and F stream, we need IO manip because we are manipulating the characters in the file. So our header will somehow look like this one. Okay. Now we can create the shell of the program int main, and then we can do return 0. That's it. Now um, we can create the data file first. Let's say fstream data file, and then we have to open the file. But before that, let's define a variable double, and we can say x equals 17.6742. That is our uh, variable that we are going to store. You know. Uh, Now we can open the data file dot open, and we can say um, outfile.txt. I mean some file name, and then we have to open it in a uh, output mode so that a new file will be created. I mean, if there is an existing file, it will be truncated. So then what we can do, we are simply writing out something. We can, so in order to, let's say we are writing in fixed point notation. So then we have to do data file, and then this symbol we can write fixed. I mean, fixed is for fixed point notation. This is a keyword in C++, you know. It's a C++ keyword. It's not some variable that I defined. It's a C++ keyword. That denotes that our format will be fixed point notation. Let's see what it is. And then we can do data file X, we are reading it, end line. Okay. So we are outputting this thing, and then we can do uh, just simply we can uh, do data file dot close, so that will create the file on the disk. Let's save it. Let's try to run it. So f3 dot cpp, sorry, g++ dash o, f3 dot exe, f3 dot cpp. If we do that, then dot slash f3 dot exe, if we run it, so we have created outfile.txt. So here it is, and you can see this is the fixed precision, you know. So basically we did 66742. So basically there are six, it is up to 6 decimal point we wrote. So now we can think about uh, different formatting. So let's say we are writing we are writing up to fourth place of precision. That is the actual file, the way it was written. I mean, actual variable is written in that way. For file, if we want to do that, it is simple. So we can do it this way. And then if we run the program, compile and run the program, so uh, it will be like this, fourth decimal. Now, let's say we have to put it up to 3 decimal or 2 decimal like money. So what we need to do is I'm just copying pasting two lines at a time. So here we can do two, just like dollar amount, the money. So that's about it. And then if we execute it again, like if we compile and execute it again, we can get this one. Where is this here? So you can see two up to two decimal precision it goes. And similarly, you can set precision to be one and so on. So that's it. I mean, that's the way you format your output. Okay. Any question? It's simple. So what you need to know, um, basically, uh, we have used the set precision, of course. We can use other examples, the show point, set W, etc. But it requires IO manip. This is the header that you require in order to do some elementary format, some formatting. So IO manip is the key for doing the formatting, you know. So so that's it. I mean that's pretty much it is. Now it may be so. Let's give some example of set WX. Now when do you use that? What is that? Set WX is basically you are creating the width of the field. Why you use that? You know, in the standard files, let us say you are writing the file, writing a data file consistently from an application, and you know that you are storing, let us say, social security number, which is a 9-digit number. So in order to store the social security number in a column and make it visible, you have to reserve the space for it, right? For look and feel. So this is input output. We are reserving the field number of characters. So that is the set width function. So that is how you do that. So if we just do a quick example on that, I'm not right. We have to do little fast than what you are doing right now. Since these are the introductory concepts, I'm taking little time. So we have this one. And then what we can do, I'm just simply uh, importing a program here. So here what we can see, this program writes three rows of the number to a file. So what it does, we call standard three header files. IO stream, that is for see out, see in stuff. F stream is for files, and IO manip is for manipulating or formatting the output. So here we have to write three rows, this is the three rows, and we have to write three columns. So let's define the numbers in this way. You have rows and columns defined in this way. So you can see, I mean, that's the way you could define the number. And then you just create the output table.txt, and then you are writing three rows. But here is the deal. You are setting the width of each column to be of length 8, means 8 character wide columns. So each column will occupy 8 character. So what we are doing, we are writing each of the row here. The characters are spaced uniformly, and then the outfile end line, because we are basically line by line we are writing, so we have to write one line first, second line second, this one third, and then we are closing the file. So if we simply save it and try to run it, what do we get? So we have F4, and then if we do F4.exe, it is done. But what is done? So we have the file name table.txt. So here table.txt, we got it there. So you can see this table looks very nice because it is very uniformly spaced and consistent width of the columns. So when you need to show something to user, you should consider using the set with function. So that's the way you formulate your output. Okay, let's move forward. So we have done this. Now passing the file stream objects to functions. Uh, what are the file stream objects in the first place? I mean, basically, when we say file stream object, we are talking about, let's say, sorry, what is happening? I did not do it right. Pane, yeah. So let's say, let's define f stream x. It may be input or output, whatever it is. So this is called the f stream. X has a data type of f stream. When we talk about f stream, this is that. Now we have to pass the f stream to the file, to a function. You know the function, right? Function is the modular part of the code. Its signature is you have some data type in the beginning, then you define the function name, then you define the argument. The one of the arguments should be the file stream in our case. And so it will be like, let's say we have an integer. I'm just writing a random fictitious function, integer, let's say xyz is the name of the function. Let's say we can say if stream if this is the file. So you could do it in this way, right? So an example here, I mean, I'm not working out this example. I'm just choosing to show you the slide. So we are using mix and match technique. Sometimes we are going to write code, sometimes we will show the example. This time showing the example. So you can see, as usual, you are calling these three headers, you know, these three. Now your functions are open file input. So here you pass it by reference fstream and a string object because your file name should be there, and your contents are being shown based on the input stream. So what you do, you define an input stream and then you open the file. Um, just opening, you open the file and then it will show the contents here. So we did some kind of automation. So what does open file mean? So you have already opened the input stream, I mean f stream. So when you open the file, you just do the name, I mean file name as a reference, passed by reference string name here. Now you can open the file in this way, file.open. This file is file, I mean this whatever you pass by reference. Why you pass it by reference? Because file is an object, and accordingly it will be like you cannot just, it's not an ASCII data. It's a complicated data. Uh, it's a binary data and it's complicated data. So you are passing by reference, so you don't need to recreate it many times, create multiple copy. You don't create multiple copy. So then file.open name, this in option means it's an input file. Then if the file is fail, another function fail means you cannot open the file, then you return the false, otherwise you return true. That means you are opening the file. Okay. So then you have the show contents function. So basically you again pass fstream by reference for the same reason, and then you define the line, and then what here we do it little differently. While file, you have more lines in the file, uh, and you read the files, then you see out the lines. That is it. That is your program. So that's about your opening the file, uh, I mean passing the file objects, file stream object to functions. Okay. So you can do some error testing as well. So there can be some directives for error testing. So you do input iOS EOF bit. I mean, it is set when end of the file is detected. So you can, if there is any error in reading the file, there are certain bits C++ does for you when they handle the file. When you use C++ fstream to manipulate your file, then it gives you this I mean these methods EOF bit. There is a fail bit sets when operation fails. Hard fail, it says with error, says when error occurs and no recovery. Bad bit is when invalid operation is attempted, and good bit is when no other bits are set. So member functions you can use EOF. I mean this function is used if EOF bit is set, false otherwise. Fail you can use if the fail bit is set, false otherwise. Bad is if the bad bit is set, false otherwise. Good, true if the good bit is set, false otherwise, and so on. Okay, so we have those member functions in stock. So let's show a quick example. Okay, um, let's do that. So I'm just importing a file directly, not just writing it line by line, but I'm going to explain to you line by line. So let's open a file named new file, and then you can, it is f6.cpp. So you created the file. I'm just pasting the program. So what it does, it demonstrates the return value of the stream object I mean stream, and it is object error testing member functions. So you can see you are showing the show states. I mean, so you have you have input integer number equals 10. So then you have the test file start.dat, and then it is written in the output mode, meaning you are outputting something into the file. So if the test file fail, then you cannot open the, I mean, you have to, you are opening, if you cannot open the file, when does it happen? Suppose this is a read-only folder, you cannot open the file, so then you have this error. Now you can write something to the file. You can say writing something, test file. I mean, this is the way you can write something to the file. So you can, is it writing thing? It is writing thing, and show the bit states. So you do the test file show state and choose, I mean, close the file here. You can reopen the file input mode, and then at that time, if it fails to be opened, then you get this error. Read only the value from the file, read only value from the file. So you do it. So value is written. Again, you show the bit states. So it should be what? It should be, I think it should be the good bit, because it's good. I mean, this, if you read it, if you store it correctly and you can recover, then it's a good bit. Then you can do no more data in the file, but force an invalid read operation this way, and show the bit states. I mean, basically that, close the file, and that's it. So if you compile it, so you can do f g++ f6.exe f6.cpp. You do that. So what is happening? Cannot file f, oh, it should be -o. So what is again? Oh, yeah, this way. So it compiles now. So here you can see writing the value 10 to the file. So the file status is end of file 0, failed bit 0, good bit is 1 because it's good. You write it. The value 10 was reading from the file. Your status is end of file is 1 because you reach to the end of file. Then others are 0. Forcing a bad read operation, so you basically end up with like EOF bit 1, failed bit 1. So that's pretty much the standard way of getting the status, the state of the file status. So this is a very useful code. I mean, people use this type of code in many places in their real life applications. Okay, any questions so far? If not, let's give a quick break. I mean, let's break for 10 minutes and come back by let's say 8:10 to 8:11, and we'll be continuing that to the end, to until the end of this class. So we have already discussed about it in an example. Now you can have the member functions for reading and writing the file. So there are member functions that we have already used that are getLine, get, and put. What does getLine do? It reads input including white space. Just note this, including white space. Okay. Get basically reads a single character. Put, it writes a single character to a file. Okay. So the getLine function, there are three arguments that are expected here. The name of the file stream object, of course, where you are reading, and then name of the string object to where you are storing the line, and then the delimiter character of your choice. I mean, you can use tab delimiter. I mean, maybe you have the tab delimited. If you leave out, then the new line is the default for the third argument. Always remember that. So example here, I mean, like you do that and then you see, I mean, it's just like test.txt kind of, that's what we did. So you have get line, name file and input. So that means your third argument is the new line here. You did not put anything. That means your third argument will be the new line argument. So yeah, I mean, that's pretty much it is. We are not going through detail. Now, the single character, you use the get. Single character input output, you are using get. It reads the single character. So basically you do file name, whatever file, dot get, then you have the character variable here. So it will read any character, including white space. Always remember, it will include the white space as well. Put, basically, it writes a single character to a file. Okay, so you have this one. Now, if you work with multiple files, you can have more than one file open at a time. That's what we did, right? I mean, when we used the example to read and write, read from a file and write to a file. Let us find out the example that we did here. Not this one. Uh, Probably, no, not this one too. I think this one. We have an input file. We have an output file. This is an example of multiple file handling. So, the files may be open for input or output, and you need to define the file stream object for each of the file. Always remember, you cannot just use same file stream object for two files. This is a common error, common mistake, programming error people make. Don't use that. You have to use different file stream object for each file. So, example, I mean, we have already gone through that. Let's not be bothered with that. Now comes the binary files. So that is, I mean, the binary file, it contains unformatted and non-ASCII data. ASCII data means, I mean, whatever you see on the screen, this is the ASCII data. You can read it. But a binary file, it contains unformatted data. So you have to indicate using the binary flag on open. So you have to do iOS in and iOS binary. You have to use the pipe symbol. Whenever you use more than one mode of opening, then you have to use the pipe symbol. Okay, so that way you can include multiple modes at a time. So you can read and write instead of then you have to use read and write instead of these functions. These are for ASCII. Remember, these functions are used for ASCII, not binary. For binary, you have to use read and write. So you do in file read, and then you use the uh, pass by reference address. So that's what we did before, right? When we pass a stream. So basically, why we do that? Because binary data is complex. It may require more spaces to store the data. Rather than manipulating the data, we can just simply creating a hard copy of the data. We just create the reference and just pass it. Now, uh, additional thing you have to do is the size of function. So how many bytes do you read from the file? Send a character to the file, you can do simple this way, out file write. Now the question is, can you use your ASCII characters to um, for can you use your ASCII characters with the read and write? Of course, you can do that. So to read write non-character data, you must use the typecast operator. So non-character data means if you have an object, for example, then you have to use a typecast operator. So this is the typecast operator. You see reinterpret cast, and then you have this character star, and then you put this one. Send a binary file to a binary value to a file. You have to reinterpret cast. So remember to use reinterpret cast. So that's very important knowledge, you know. So I mean, typically you do that in that manner. So so you can, I mean, we can have an example for instance. Here, let's open the file again. So let's create a new file. We can call it f7.cpp. Okay, and I'm just importing the file. So not writing it from the scratch, just importing the file. So you can see, I mean, it uses the write and read functions, you know. So I say it doesn't matter you use ASCII character to do file manipulation. If you have ASCII character, you can still use the read write functions. So you have to open the output in the binary mode. So you have file open, let's say number.dat. This is your file, and then you have input and it is a binary. So write the contents of an array into the file. So you get writing the data. You are writing the data to the file. So what do you do there? You do like file.write, and then you do reinterpret cast. So because you are doing the binary mode content, that you are writing the data in the binary mode, then you close the file. Then you open the file again and then you read it in the binary mode. Now you can read the contents back inside the memory. So you have to use reinterpret cast again. Remember this one, reinterpret cast, and then you can display everything. So let's run the code first and let's see what actually happens. So if we just do, let us say F7 G++ dash O F7 and then F7.cpp. If we do that, okay, dot slash F7 dot exe. If you do that, then I mean, we wrote the data to the file. Which file? Numbers.dat. Let's try to open the numbers.dat. Let's see what is there. So mn here. So, I mean, numbers.dat is a binary file. So you see, this is, you don't understand what is written because it's in a binary format. Binary format is more compressed format. So you don't need to write. I mean, you don't need to know what is there. Only thing we make sure that we wrote it in a binary format. Now we open the file for input in the binary mode as well. So you open it. So I mean, the C++ knows that it is opened in the binary mode, and then you read the file. So you have to use reinterpret cast. You know, the cast. I mean, in the first place, you are putting some numbers, which are the ASCII numbers. So you have to reinterpret these ASCII numbers into character object. Okay, that way you are storing them in the binary mode. When you recover them, you have to use the exactly same thing, but then in that case, you have to bring back the numbers out, I mean, bring back the ASCII characters out of the binary. So that way you just do it in this way, and you just, you can see that we recovered everything. So the key point that you need to know here, you have to open the file in the binary mode. That's number one. Number two is you have to use the reinterpret cast when you write to the file, when you recover the content from the file. In both cases, you have to use reinterpret cast. Okay, any question? Okay, let's move forward. So you can do the creating records with the structures. We have learned about the struct. Now the thing is, the structs are, the struct, right? I mean, last week we read we talked about struct. You have another video loaded there. You can see you can talk about where we talked about the cast. In the just past week, we have uploaded that video and we discussed it. So, I mean, when you have created a record with cast with structure, the structure you cannot, these are not ASCII objects. These are structs are not ASCII characters. So you have to store a struct in the binary format, and you have to use read and write member functions. Let's see how they do it. So first, let's create a struct like test score. We have done it last week. So you have this struct. This is like a compact object. So you instantiate this struct and create an instance of this struct, and you write one test. Now you have to write one test to a file. So what you do the grade file write, I mean, you do it, you write it, but you are reinterpreting the cast into the characters, and then that's the way you store. So what we are doing, the objective is, I mean, in the previous case, we stored the ASCII data. So that is more spacious. I mean, it needs more spaces. Rather than that, if you compact your data into the structures, you can store the structures itself. In fact, this concept is a keynote, is a key to create an object-oriented database. So in the object-oriented database, you don't store the numbers, you don't store the letters, you just store the objects. Okay. So for example, if you have, let us say you have a drawing package. Now you are interacting with the database to retrieve some dimensions from there. Let's say you have a sphere or you have a circle that you are going to draw. You need the radius. Now the radius is stored in the database. So this can be done in two ways. I mean, you can, database means files. I mean, I'm sorry. So you store this in the file. You can store the radius in an ASCII file and import that, or you can just store the structure, the circle, the whole structure inside the file, and then import that, and then reinterpret that. So why we use this? Because in the drawing packages, it is hard for us to keep track of individual numbers in that way because it's more spacious. And number two is that sometimes for doing some secured communication, we need to do in the binary mode. The ASCII mode is always very, very spacious compared to binary mode. So let's say you have a huge data file. If you compress it in a binary mode, then you can simply recover it, reinterpret it, and then get back whatever you were doing with that. Okay, so that's the concept. Now you have the random access files, the sequential access. You start at the beginning of the file, then go through the data in the file. That's what we have done so far. Like line by line, I'm reading in order to end. To access the 100th entry in the file, you have to go through 99 preceding entries first. The random access means you are accessing the 100th entry pretty directly. So that way you are using seek kg, seek kp, these two functions. This is seek get and this is seek put. So it is used to file open for input. This is used the file open for output. Okay, so that's those are the two interesting functions, seek kg and I mean seek kg and seek kp. So those are I mean that is a kind of random access file. Let's give an example. Okay, so let's go back to our uh, VS Code. Let's open a new file called f8.cpp. Okay, so we do that. I mean, I'm just putting the code here. So what is happening here? Nothing new in the header, but here uh, character, it holds the character. Let's say we have a file letters.txt and let the letters.txt be all the letters. So basically open a file and store all the letters and then you save it. Um, you can say letters.txt. Okay, so that's it. It's simple. So you have it here. Now you can open the file for input. It's simple. You do fstream file name, whatever name, and then input mode. Now move the byte 5 from the beginning of the file. So one character occupies 1 byte. So you just use file.seek_kg and then you do 5L, uh, 5 bytes basically. That means you are, and from the beginning, that means input output ios beg, that is the beginning of the file. So then you get the character. So byte 5 from the beginning you will get. Now move to the 10th byte. So again from the end of the file. So you are going back. So minus 10L, that is you are going back from end to the uh, I mean just 10 character after 10 before you are basically rewinding the file. So then you use, and your pointer is at to the end. So that's how you say, I mean that's how the program knows that you are trying to go to the end, and then you want to just go back 10. I mean you just move back to the 10th byte from the end. Okay, so basically if you have um, I mean, if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so you are from 11, you are going to 1. So that's pretty much going to 2. That's pretty much your moving. And in this case, from 1, you are moving to 5. That's your moving. So if you do that, if we just save the code and just do f8.cpp, let's see what happens. f8.exe. So you see byte 5 from the beginning. So our is F. So why it is F? Because if you go to the letters 5, 1, 2, 3, 4, 5. So 1 to 6, sixth one. This is the byte 5. Now 10th byte from the end. That means you are doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you get it here Q. Byte 3 from current from here q to byte 3, so you are you ended with 1 2 3, so here. So that's the way you are I mean randomly accessing the things. Think about uh, of a vinyl records. I mean I don't know how many of you have seen that, but this was like that. I mean there used to be a disc, and you have magnetic or some magnetic regions, circles. So you have they used to store the songs out there. So then if you seek certain, if you go to certain point, you will listen some part of the song. It's same as like magnetic disk on your computer as well, on memory device. There are two types, magnetic disk and also the solid state disk. Solid state is different, but magnetic disk is the one that you use by seeking something. Literally you run the seek function from the C++, because if you are using a Unix system, it's written in C++. Linux, for example, if you use a Linux operating system, it uses C++ language or C language. So it uses the seek functions to get to certain point of the disk, to read that and then get the character, store that in the memory, seek another point, and that way you can see. Sometimes you will listen that if you are using a computer with magnetic disk, you will listen the sound of the disk rotating. But solid state device works in a different way, so that's a completely different story. We are not talking about operating system here, but it's good to know where we use those kind of things. Okay, so that's about it, and let's not be bothered about that. Now, opening a file for both input and output, that's a very critical thing. It's a very edge cases. So very simple, you have to write it in this way, in and out. You can also use the binary for the binary data. So that's pretty much it is. So you are reading something and then you write something. So this is the way you should do it. So working with the file system, so basically, there is a in C++, 17 and later, the standard library provides numerous functions for and types that you can use to work with file system. The file system is like in your operating system, there are files, right? And the files are stored in certain structures. So that's where you use the file system. And that's why that's the time you use that file system tag, you know. So um, I mean, I don't have any example for that, but basically you include this one. Okay. So then all of the file system functions and types are in file system namespace, which is in the std namespace. Like using std, using namespace std, when you do that, then you can use the file system namespace as well. So directory, for example, if you want to navigate to the through the directories and files, you can use some file system, that header, and use the underlying functions inside member functions of that to navigate through it. So that's pretty much about the file system. So it is a C++ tool that is used for navigating through the whole file system, you know. So that's about it. Let's give an example, right? I mean, without example, it doesn't look good. So let's write another code. Let's do f9.cpp. Okay. So create the code. That's good. So what we do first, we import the settings. I mean, the include files. We use the include files, int main. Then you do this. Sorry, and then return 0. That's it. I mean, that's a shell. I mean, we need to be in the habit of writing the code in that way. Again, I'm saying the same thing. So string, let us say target. Okay. Then what we do, we can get the path of the file or directory. So you can say cout, uh, enter the path of a file or directory. Okay. So you can do get line scene. These are the known things, I mean, target. So you are just doing the path name. That is, if you are on a Windows Explorer, your path name should be like C drive, something like that. Now you can, I'm going to give you example. File system, and then you can do um, path. You can say target path. That is an instance, and then you can say target. So that's how you define the path, you know. Now, does the file exist? Does the target exist? So you can say if file system exists, target path. I mean, if the target path at all is there. Sorry. Yeah, that's it, right? You can say that cout target path exists. Else, you can say, like here, this end should be small letter, not the capitalized letter. Else, you can write cout path does not exist. Okay, that's simple. So let's try to run the code. I'm not sure how we are going to run this code, but let's try. So let's do this like F9. Okay, dot slash F9 dot exe. So enter the path of file or directory. Let's say I'm using my this. Let's say I'm using my file system on my Windows machine. So let's say I'm using this one, this path. Does it work? So if I put it here, sorry, no, not that way. So actually I should have written it in this way. That should be better. Let me quit the code and do it again, compile it again. Okay, now, so I can do it app dev, So it exists. See, I mean, that's how, I mean, basically you have to specify a certain folder. If that folder exists, it says it exists. So what we did here, we defined the file system path, okay? And that's the target path, and that is the target. I mean, target is this one. So our target path for this file system path, this is the object, and this is the instance of the object. And then if that exists, then we write exists, otherwise not. So let's say something that does not exist. So let's say C colon, let's say test 1, 2, 3, 4, 5. This folder does not exist in my directory at all. So it does not exist, it says. So if we go to a file, for example, let's say I have, let's say what I can have. Let's say I have this one and this one. This is a file, right? Cart is a file. So PHP file. I mean, it's a just so if I do this, so we have demonstrated it for a directory. Now we have demonstrated it for a file, cart.php. So it exists. This file exists. But if we do um, cart.php1, which is not there in any way, php1, then it will say path does not exist. So basically it tells you whether a path exists in your file system or not. So that is pretty much it is. So it is used in different parts. I mean, like if in your operating system, this is the way it can detect whether a given folder, given path does exist or it does not exist. Okay, any question? Good. Okay, so that's about it. That's what we did here. I mean, we basically did that. An absolute path is like this, or you can do the relative path as well. I mean, that's another way to look at it. So that's fine. I mean, an example that you could do like the content of a total printing the whole directory tree. You can try it yourself. I mean, look at examples online or in the book to find that. Okay, so that is fine. We have done Windows example this way, and you can use the raw string as well. So let's you can copy a file. You know, file system has a function to copy a file from one path to another path. This is also used actively in the scripting areas, or maybe in some program. I mean, you want to copy something, manipulate the file. Sometimes you know you do in a perfect use cases like that. Sometimes your program requires to create a file, and then it there will be another program that will capture the file, consume it. Maybe it will transfer the file to another folder. Once you transfer, there needs to be some way for the program to mark it. So a way is create another folder called archive and place it inside the archive folder and delete from the original folder. So basically in that case what you do, you simply uh, you simply go and just copy the file, or you can have, probably you have the moving the file also exists. I mean, basically you copy the file and then you remove the file. That will work. That is moving, right? Copying first and then removing from the existing one. That is the moving. So you can do that. So that's pretty much it is with the, and you can do the rename. You can do everything, whatever you want with the file system. It's a very powerful API. You can do whatever you want with that. So getting and setting the path of the current folder. So you can do this way. File system path, you can do current path. This is another member function. To do that, you can try everything. I mean, write a code just like I did. Then you can start trying out stuff. So that is it. I mean, you can create a directory. I mean, there is a function called create directory. Like in the Windows machine, we do mkdir. So this is the C++ way to create a directory. You do create underscore directory. So basically, the message here is using the file system API, you can manipulate your file system just as you do manually. So if you use C++, that means you are adding some automation to the processes, right? So in the automation process, you can do everything that you can do manually. So this is an example. I mean, using the file system can enable you to do to basically manipulate your file system. Some applications do that. I mean, some applications are required to do that, and they do it in this way. So um, you can, I mean, whatever the use cases, you can do it here. So you can, I mean, like this one I was talking about, getting the content of a directory. So you use the directory iterator for that. And also you can use recursive directory iterator. So directory iterator means if you, in this way, if you use this one, you will see only users. Visibility will be up to users. But if you do recursive, then it will go into users, find Blake, for example, then it will find all the objects inside Blake. So that's the way it does the recursive directory iterator. So yeah, that's a good example. So whatever I was trying, I was saying to you to try, it is there in the slide itself. So uh, yeah, I have uploaded your slides and this video is also available. So you can take a look. Okay. So this is these are very good. I mean, it's a good, very powerful API, and you have the directory entry object. There are multiple functions within that object. So it is given there. So there are other stuff. I'm not doing particularly anything related to the function called chaining, but basically you have the file system current path, and then you have the file name, then you have the string. I mean that basically you are chain your functional calls. But I mean, what I recommend you is to go through your file system API and then you write some code by yourself, get yourself familiar. This is a very good code to start your like journey with the file system. I mean, this way you will learn a lot about the file system. Not start the journey, but you should use this one. You should write this one. This type of code is very useful when you work for some project, or sometimes they will ask you to do this. So it's a good way to see the recursive view of your directories. So that's pretty much it is. So any question you have? We reached to the end of this presentation. So question answer time. Any question for me? So good job everyone for keeping up with your assignments. I do see that every week the assignments are labs are popping up on the grading as a grading assignment for me. Many of you are just reaching out to me telling that you have completed this and that. That is great. Yeah, I mean, what we want to do is that we don't have to learn everything, but we have to learn absolutely what we are trying to learn. Like we can learn little, but that should be very robust. So that's the approach I am adapting in the class. I'm trying to build the subject in a way that you learn it. That is the main purpose. And then, of course, I mean, if you learn it, your exam, everything will be good once you learn it. So I think we can stop here. This is a good stopping point. And unless you have any questions, so we will talk to you again in the next week. And in between, if you have any questions, any problems, just feel free to send me messages, email to the school email address, or Canvas also works. Uh, just keep sending me messages, and I will be responding to you as soon as I can. So, and if I don't respond to you, just remind me one more time so that I find it on my mailbox and go back to your original message. So that's it. That's all about it, and hopefully talk to you soon in the next week.